Today we're going to learn about how you put the information you have in to create a process flow diagram. In general, a process flow diagram has arrows showing the direction of flow. We've got input going in. We have a process that is acting on the inputs to create the outputs. So we're going to start with a simple example of an ice maker. And this ice maker is going to be. So what we're going to do is we're going to take our input of water and we're going to fill up an ice cube tray that has 14 cubes. And we'll put the ice cube tray into the freezer, wait for the ice to freeze, remove the ice cube tray from the freezer, and dump out the ice cubes to give us an output of ice cubes. Now we did this all as a batch process in that we made one ice cube tray, and if we want to make another one, we start the process all over again. So in this case, the input is water. The process is freezing the ice and into ice cubes, and the output is ice cubes. Now the mass of the water in is what ends up being the mass of the ice cubes out. This process does not change the mass across. The next example we're going to look at is a blender or a mixer. We want to make a milkshake. So what we have is some milk, some frozen berries as our input. They go into the blender. Again, you run the blender for a while, the desired time. When you're done, you then pour out of the blender milkshake. Again, a batch process. Everything goes in, process runs, and out comes the milkshake. Total mass of what we put in the process comes out in a different form. The next process we're going to look at is the process of screening or filtering. We want to separate water and gravel into two separate streams. In this case, we're going to feed the screen a continuous slurry of gravel and water, and then we want to separate it out into a continuous stream of clean water and gravel. So unlike the previous two examples, this is a continuous process. So when you're looking at continuous processes in mass balances and process flow diagrams, you look at it per unit time. So if we're feeding in a kilogram per minute as an input, the total outputs will be a kilogram per minute created into flows. Now let's look at something a little more complicated. For example, a coffee maker. We probably all have coffee makers at home, and you think pretty straightforward. And as far as a industrial process, yes, they are. They actually consist of three different operations inside the coffee maker. First, we add coffee bean, runs through a grinder, and the coffee falls through into the filter. The second process is a heater. We pour water in, the water is heated up, and hot water comes out and goes into the filter. So the output from the grinder and the heater become the input for the filter. The hot water runs through the ground coffee. Some of the coffee grounds dissolve and make your pot of coffee. And what is left in the filter when you're done is waste coffee grounds. So in the overall process, you add coffee beans, you add water, get a pot of coffee, and waste coffee grounds. So both the pot of water and the waste coffee grinds are a mixture of coffee and water. And again, the total mass of the coffee beans plus water equals the total mass of a pot of coffee plus the coffee grind.